So now that we have our library of functions kind of in the back of our head just kind of ready to go, we're going to talk about how do you use those to graph more complicated functions. And what this is called is graph shifting. So graph shifting. So there are a couple things that you can do with graphs, depending on multiplying their function by numbers, adding numbers to the functions, etc. So the first thing you can do is you can move a function up or down. So you can move f of x up or down. So this is a vertical shift. So this is also called a vertical shift. What we're going to do if we want to move f of x up or down is you just take your function and you add a number or you subtract a number. So adding a number to a function or subtracting a number from a function, that's just going to move it up or down. So, for example, let's say I want to graph x cubed minus 2. Well, you know what x cubed looks like, so we're going to start with that. Start with what you know. You know what x cubed does. From there, we're just going to take it and subtract 2. That's a vertical shift down, so we're going to take this point that was at the origin and move it down 2 places. Same shape of the graph, only we've moved it down 2. So the reason we're doing this is we're taking what you know and just kind of shifting it. So for this one it was x squared minus 2, so you just take that graph and kind of move it down 2 places. So that's a vertical shift. It can go up or down. If k is positive, go up. K is negative, go down. So we can move up and down. We could also move f of x left or right. And this is going to be a horizontal shift. Horizontal shift. So with the vertical shift, if you think about this, the vertical shift we were taking the y values, which are f of x, and we were adding and subtracting. So for the horizontal, this is more to do with the x values, so now we're going to be adding and subtracting from x. So if you do x plus k, you would think this moves to the right, but it kind of does the opposite. This moves left k units. If you have something that's x minus k, you would think it should move to the left, but it doesn't. This is going to move right. So this is moving right k units. So we have our vertical shift, where you're taking a function, those are your y values, taking a function and adding or subtracting a number. Then we have these horizontal shifts, where you're just adding or subtracting from the x value. Because horizontal, remember that horizontal axis is your x-axis. So adding or subtracting from your x's is going to do a horizontal shift. So for example, let's look at the absolute value of x minus 2. So start with what you know. We know what the absolute value of x looks like. This is the absolute value of x, so start with that. How is the absolute value of x minus 2 different? Well, instead of an x, we have an x minus 2. Since I'm replacing x with something else, that's going to be a horizontal shift. You would think that we're going to move left with that minus 2, but we don't. We kind of do the opposite with our x's. So this is really going to take this point that was at 0, 0 and go right 2 places with it. And then have the same shape graph, just moved over 2 different places. So I have horizontal shifts, adding or subtracting from my x values, vertical shifts, adding or subtracting from my y values. We can also flip across the y-axis. So flipping across the y-axis, if you remember when we did symmetries, for symmetric about the y-axis, we kind of replaced our x with our negative x. So flipping across the y-axis is where the x has been changed to a negative x. That's the only difference here. So for example, let's look at negative x cubed. So here the x has been replaced with a negative x. So start with what you know. We know what x cubed looks like. This is x cubed. Instead of an x in our function here, we have a negative x. So I'm going to replace x with a negative x. So what does that do? It flips it across the y-axis. So I'm just going to kind of mirror this across the y-axis, and this is negative x cubed. So we have vertical shifts, that's where I move up or down. I have horizontal shifts, that's where I move left or right. We can flip across the y-axis, that's making x negative x. Well, we can also flip across the x-axis. So we can flip across the x-axis. Just like flipping across the y-axis, you made your x negative. For flipping across the x-axis, this is where instead of a y, we have a negative y. Or instead of an f of x, we have a negative f of x. Because really f of x, those values are just y values. So for example, let's say I was trying to graph negative x squared. This isn't saying this. This isn't negative x. I'm not making the x negative. I'm making the whole thing negative, so not that. So let's start with what we know. We know what x squared looks like. Instead of an x squared, we're multiplying the whole function by negative 1. That just flips it across the x-axis. So it makes all of my x values, or all my y values, negative. So there's my graph of negative x squared. We can also stretch or compress vertically. How this is done is multiplying the k by a number. If k is bigger than 1, we're going to be stretching. If k is smaller than 1, then we're going to be compressing. So if k is bigger than 1, it's a stretch. If k is less than 1, then we compress. So for example, let's look at 1/2 x squared. Well, we know what x squared looks like. Here's my graph of x squared. I'm multiplying the whole function by 1/2. Well, that's less than 1, so this is just going to kind of compress it. So it's going to make it a little bit kind of more spread out. If it would have been 2x squared, then I would have stretched it. So it would have made it more vertical. And then lastly, we can stretch and compress horizontally. So what we mean by this is, instead of having an x, you could have like a 2x, or instead of having an x, you could have a 1/3 x, something like that. So this is where we're multiplying the x by a number. So it's kind of the opposite, just like you would think. It's kind of the opposite as the vertical one. So for this one, if k is greater than 1, then we're going to compress. And if k is less than 1, then we stretch. It's the opposite of the stretching and compressing vertically. So for example, let's look at the absolute value of 2x. So start with what you know. This is my absolute value of x. We know what that looks like. And what are we doing? We're multiplying the x by a 2. I'm not multiplying the whole function by a 2. I'm multiplying just the x by a 2. So what does that do? Well, that's going to compress it horizontally, not vertically. So it's going to kind of make it a little more pushed in on the sides. So this is the absolute value of 2x. So we have our 6 different ways that you can manipulate a graph. You can move it up or down, move it left and right. You can stretch it or compress it both horizontally and vertically. and we can flip it across the x-axis or the y-axis. So let's just do a couple of examples of this. So let's say that I'm trying to graph the equation negative 3 times x minus 1 squared plus 1. So it looks really complicated to graph, but kind of take this piece by piece. Pick a function that this kind of looks like that you know. Well, we know what x squared looks like. That's not our function, but it's something. So I know what x squared looks like. Well, how is our function different than x squared? Well, there's a lot of things, but let's start with, we don't have an x, we have an x minus 1. So what does x minus 1 do? That shifts it horizontally. You would think that it should shift it to the left, but it doesn't. It goes right. So it takes my parabola, and it moves it 1 unit to the right. So this is the graph of x minus 1 squared. So we're getting closer. We have the graph now of x minus 1 squared. Let's deal with that negative 3 next. So since we're multiplying the whole function by a negative, that's going to flip it across the x-axis, but also we're going to stretch it because of that 3. So our next step is we're going to multiply the whole thing by negative 3. Again, that flips it across the x-axis, but also stretches it. So I'm going to make it a little bit stretched and flip it across the x-axis. So this is negative 3 x minus 1 squared. Oops, just that part. And now we're almost there. What's left? We just have to deal with that plus 1. So we're adding 1 to the entire function, which means all we're going to do is take that point that was on the x-axis and move it up 1. So this is my final graph. So again, what do? We started with something that we knew. We knew what x squared looked like, and then we kind of manipulated it to get the graph that we want. So just take it piece by piece and get the graph that you want. Okay, what about f of x is going to be 3 over x minus 2 plus 5. So what does this look like? So just pick a function that you know that it looks like, probably 1 over x. So let me draw our 1 over x here. That's not the graph that we want. And if you think about it, 1 over x kind of has this imaginary line there that we can't really cross at 0. So we don't have 1 over x. Instead of an x, we have an x minus 2. So I'm going to deal with that next. So we don't have an x, we have an x minus 2, which means everything needs to shift right 2 places. So I'm going to have that kind of imaginary line shifting over 2. So this is going to be the graph of 1 over x minus 2. Next we have this 3 to deal with, so I'm multiplying the whole thing by 3. Multiplying a whole function by a number stretches it, if that number is greater than 1. So all this is going to do is stretch. Still have this imaginary line here at 2. So it's going to kind of make it, and this is real hard to see here, but it's going to kind of make it more vertical. Good. And then we have this plus 5 to deal with. So what does that plus 5 do? Well, we're going to shift up. Remember, adding 5 to the whole function shifts the whole thing up. So instead of having this line here at 0, we're going to be moving up to 5. And then I still have this line at 2. And here's my graph. Hopefully you can see this. I'll draw it a little bit better on the next one, but I still have this line at 5, and I have this line at 2. So, a much better drawing. I have this line at 5, I have this line at 2, and then here's my one piece that was there, and then here's my other piece. So all I've done, shift stuff over, shift stuff up. But the point of it all is to start with what you know, and then kind of manipulate from there. That's what we're doing with all these graph shifting.